NASA Connect traveled south from San Francisco to Long Beach, California for today's hands-on activity.
We're from the Boeing Summer Science Camp.
NASA Connect asked us to help you learn how to do the show's hands-on activity.
It's called In the Safety Zone.
Here are the main objectives of this game. You'll plot initial aircraft coordinates using a rectangular coordinate system. You'll use measurement tools and techniques to determine distance. You'll apply ratios to calculate the Air Safety Travel Index. You'll calculate initial aircraft distance versus actual aircraft distance traveled. And you'll work in teams to solve problems related to your own air traffic control challenges. The game board and a list of the materials you need are included in the lesson guide, which your teacher can download from the NASA Connect website. The class will be divided into groups of 4. Each group will get a flight plan to record the landing times, a tracking chart to track the progress of the assigned planes, a safety rating card to keep track of the total points earned, and the game constraint card. More about this later. Each student or air traffic controller in the group will be responsible for 3 aircraft and one of the quadrants on the game board. Your primary goal is to land each aircraft safely and on time. Now let's get started. Using the initial aircraft flight coordinates provided in the flight plan, plot the starting position for each aircraft on the game board. Use a pen along with the correct aircraft cutout to mark each starting point. Record flight number, aircraft type, and runway information on the tracking chart. Choose a colored pencil and color each designated aircraft to ensure correct tracking. Now measure and calculate the direct distance in kilometers from the assigned aircraft to the airport using the scale 2 centimeters to 5 kilometers. Record the information on the tracking chart. For each minute of play, all aircraft must make one move. One move corresponds to 2 centimeters of linear travel, 5 kilometers. Use your metric ruler to verify 2 centimeters of movement. Aircraft cannot move backwards on any consecutive move. During each minute of play, each ATC must keep track of his or her aircraft's flight paths using a colored pencil and metric ruler. After all paths have been updated, place a check mark on the tracking chart indicating completion of your aircraft's move. Check the game constraint card for landing guidelines. Study the flight plan, particularly arrival times and runway locations. The game proceeds as your teacher follows a script which indicates when to move and when conditions change. When you're finished playing the game, calculate your score using the instructions in the lesson guide. Now you're ready to determine the Air Safety Travel Index by calculating the percentage using the ratio of team points divided by total possible points. Complete the tracking chart by calculating the actual linear distance traveled from the aircraft's initial coordinates to the airport by using this equation. Calculate the difference in the direct distance traveled versus the actual distance traveled. Your teacher will conclude the game by discussing some questions with you so you can apply what you've learned during the game to the actual job of an air traffic controller.
All right, you guys need to take a look at your Air Safety Travel Index. It should be at about 100%. If it's not at 100%, there's probably a reason for this. Do you guys have any idea why it wouldn't be at 100%?
Because my plane had to fly around the mountains.
Mine was late because my runway was closed for a few minutes.
Special thanks to the AIAA chapter of Cal State University Long Beach and to Boeing Summer Science Camp for their help.